Hi everyone, welcome back. Lastly, we continue on this feature detection and description module, and we learned brisk, and today we are gonna start to a new one, which is SIFT. Also, I can say SIFT is the most famous one. SIFT stands for Scale Invariant and the Feature Transform, which is meaning that also is also telling us the main advantage of the SIFT, which is scale invariant. What does this mean is that, for example, you have two different kind of resolution images, and you are trying to match the similar key points. In that case, the SIFT is gonna give you the good descriptors to be able to compare, and you can easily say those two key points are same or not, so they are different maybe. Yeah, so this is basically giving you that information. Also, you can still have the similar images, have the same resolution images, but you have different size of the similar object. So in that case also, for example, one image is closer to your object, which is zooming, which is have different kind of area pixel in the pixel wise. So in the other one maybe is far. So in those cases also the SIFT is gonna work finally comparing to the other feature detection types. Okay. So this is basically a simple introduction. Also, similar to the other ones, first of all, in this video we are gonna check SIFT with the other types which we already learned. Also, in the next video we are gonna focus to the member functions, the parameters this SIFT is taking. Okay, here is the new table I changed. So first of all, actually I'm just edit this SIFT line, and if you directly watch this video without watching the others, maybe you can stop and you can basically just simply checking what the difference each other. Okay, the type is SIFT again key point detector and descriptor. So it's not only detecting the key points, it's also giving the descriptors for each detected key point. Okay. And also, as I said, the main advantage of SIFT is scale invariant. So of course it is scale invariant also, yeah. And also rotation invariant, yes, also it's not even rotated your key points, is gonna be able to detect those key points, those corners. Only actually two of them is not detected because GFTT already doesn't give a descriptor. So also this MSCR also it's region based, so these two already, but the others all are rotation invariant, which is important. And also multi-scale gradient based key points, the feature type, also the others mostly multi-scale. And descriptor support, yes, this is also giving you, also in the code part we can simply compare. For example, brisk is less detailed than the SIFT. We are gonna learn why. Okay, we can switch to the code part, and this is the code from the previous video which we were trying to check brisk. How is we already checked the parameters also. And if you want to switch to the SIFT, it's very easy actually. All we need to do is just changing brisk with the SIFT. Okay, also we can change the brisk, but no need. Okay, so if we all we need to do is just changing brisk with SIFT, and it's gonna work, and it's gonna it's gonna draw the yellow circles which are on the detected key points. We can say maybe for this image this is not expected, because for me the key point should be here. Also the other corners should be the key points, but it's giving it doesn't give wrong because of the parameters, the default parameters defined. It's giving us these results, which is wrong. But in the next video, when we adapted our parameters, it's gonna give us the correct key points, correct corners. But something I want to talk about in here. So always we are focusing to the key points in this video series. We are not yet checking the descriptors detailer, because for descriptors I'm planning to at the end add another video, because the comparing descriptors are very important. So I don't want to, for each key point the description type, I don't want to go to detail of these descriptors, so I'm hiding it to the end. But we are talking less, I mean we are talking little about these descriptors, and in this video I want to talk for specific to the SIFT, because this descriptor size in here also this gonna give us the answer of why this is more detailed. For example here, and maybe I want to also check the key point size. Okay, just make an empty. Okay, now if we run this code, it's gonna tell us how many key point detector, which is 76, and for each 76 detected key points, it gives us 128 descriptor, which is descripting the corner, descripting the key points, which is you can think is an ID of key point, which is 128 number. Okay, so this is 128 for each key point. But if we back to the brisk, let's back. Yeah, now it gives 64, which is less number than the SIFT one, 120. So you can think like this is more digit after the decimal, so you have more detailed information for the SIFT key points. So this is one of the main difference with brisk, let's say. Yeah, basically in this video I wanted to talk and compare this SIFT detector, and in the next video we are gonna get into the detail of the member functions. Thanks for watching. See you in the next videos.